Okay, welcome back. This is Mr. Hassan's Maths channel, and this is question number 9 from the June 2012 Edexcel GCE Core Mathematics C1 paper, which is an old paper. This question here is a question that I think I've included in one of my homework assignments, my online assessment homework assignments. And this is question number 10, I think, from that one. It's from my P1 straight line graphs homework. So I'm going to answer this question here. This is the old C1 paper, which used to be non-calculator, and so I'm going to do this without using a calculator as well. So it says the line L1 has equation 4y plus 3 equals 2x. The point A, P4, lies on line 1. Find the value of the constant P. So P is basically the x coordinate of the point A, and we know the y coordinate of the point A is 4. So at A, the x coordinate is P and the y coordinate is 4. So these two values should satisfy this equation. So if I substitute these values instead of x and y in this equation, I should find what the value of P has to be. So you have 4y plus 3. So 4 times 4 plus 3 has to be equal to 2 times P. Okay, that's going to give you 16 plus 2, which is 19, equals 2P. Therefore, P must be 19 over 2, which you can write, if you want, as 9.5. Okay, so they didn't write the coordinates of A, just find the value of P. So that's the value of P, which is the x coordinate of point A. Right, then it says the line L2 passes through C, which has coordinates 2, 4, and it's perpendicular to line 1. So I'm going to put the equation of line 1 here so we got everything in front of us. So it tells us to find, let me just move this out of the way a bit. 1 second. Okay, so it tells us here to find an equation for line 2, giving your answer in the form ax plus by plus c equals 0. So basically, line 2 passes through this point and is perpendicular to line 1, which has this equation. So we want to find the equation of a straight line. To find the equation of a straight line, we need two bits of information. The first bit of information we need is the gradient of our line. So we know that we need to find the gradient of our line, so we need to find the gradient of line 2. And the other thing we need is a point, any point on the line. Doesn't matter where, as long as it's on the line. Okay, so the point C is on line 2, so we already have that. So this is fine. Now this one we have to find. Now we can find this because we know the fact that the line 2 is perpendicular to line 1. Okay, so if it's perpendicular, then the gradient of line 1 multiplied by the gradient of line 2 has to give you -1. They must be negative reciprocals. So how do I find the gradient of line 1? Well, I can use its equation. I know its equation is 4y plus 3 equals 2x. If I rearrange this in the form y equals mx plus c, where I make y the subject, then I can read from the x coefficient what the gradient is. So if I subtract 3 from both sides, and then I divide by 4, so I'll end up with 2 over 4, which is a half, x minus 3 over 4. So I can see here that the gradient of line 1 is equal to a half. So therefore the gradient of line 2 has to be the negative reciprocal of half. So we change its sign and turn it upside down, so it's going to become -2 over 1, which is -2, and as we said, it goes through the point C, which is 2, 4. So this is enough for us to use to find the equation of the line. So y minus y1 equals m times x minus x1. So we have y minus y1, so y minus 4 equals m, which is -2 times x minus x1. So x minus x1 is going to be x minus 2. So we end up with here y minus 4 is equal to -2x plus 4. So we have y equals -2x minus 8. So that's the equation of line 2. Y equals -x minus 8. Hold on for a second. Let's just rewrite this a bit, because they've told us to put it in a particular form, not y equals mx plus c, but ax plus by plus c equals 0. So let's go back here and write it in that form. So what I want is, it's better to have the x term as the positive term, although it's not necessary, but I prefer to have it that way. So I'm going to add 2x to both sides. I've got 2x plus y, and I'm going to subtract 4 from both sides. So 2x plus y minus 8 equals 0. So that's the form in which we should write our final answer. If it said in the form y equals mx plus c, then it would be y equals -2x minus 8. If it didn't specify, then either of them. But here we can write it in this form, that's fine. And there we have the answer to part B of this question. And now we're going to go on to part C. It says the line L1 and L2 intersect at the point D. Find the coordinates of point D. So we have the line 1. Let's just bring this down so that we know its equation. And we have line 2's equation. Okay, we have line 2's equation, which is we just found here. So let's just write them. You have 2x plus y equals 8. That's line 2. And I'll write this in the same form. So I'll write minus 2x plus 4y equals negative 3. I've just written them so the x, y's, the numbers on top of each other. I can solve this pair of equations simultaneously. And then if I solve these pair of equations simultaneously, I will find where they intersect. So I'm going to use elimination here because it seems pretty easy. If we add these two equations together, we'll get 5y equals minus 3 plus 5, which is 5. So y equals 1. And we can use one of these equations. So 2x plus 1 equals 8. 2x equals 8 minus 1, which is 7. So x equals 7 divided by 2. So x equals 3.5. So therefore the coordinates of the point D are 3.5 and 1. So we've now found the coordinates of the point D where the two lines intersect. And now we're going to answer part D. It says show that the length of CD is 3 over 2 root 5. Okay, so I think I've got enough space to do it here because it's to do the length formula. I know the coordinates of C. I know the coordinates of D, 3.5 and 1. And C, were we given those coordinates or did we have to find it? C is 2, 4. They've told us what C is. So C is the point 2, 4. So the length between C and D, we have to show it's given by this. So we have to show our steps very carefully here. And as I said, I'm not going to use a calculator for this. You have the square root of. Now, when you're finding the length between 2 points, we're using Pythagoras' theorem. So we basically subtract the x coordinates, square the answer, subtract the y coordinates, square the answer, and then find the square root. So I'm going to actually write this as 7 over 2 because when we're thinking about square roots and squares, I think that makes life a bit easier. So we're going to have 2 minus 7 over 2 squared plus 4 minus 1 squared. So that's 4 over 2 minus 7 over 2, which is negative 3 over 2. That's going to be negative 3 over 2 squared plus 3 squared. Okay, so that's going to give you the square root of, that's going to be 9 over 4 minus 9, which is going to give me the square root of, now 9 over 4 minus, that's going to be, so that's 9 over 4 plus, not minus, only minus, plus of course. So 9 over 4 plus 9, that's going to be 9 over 4 plus 36 over 4, which is 45 over 4. Okay, so we've got the root of 45 over 4 has to become this. Let's see. So we're going to have, take out, we can see here we got the perfect square of 9 times 5. So you have 9 times 5 over 4. Okay, so I can say that that's the square root of 9 over 4 times the square root of 5. Checking out the perfect square factors. And the square root of 9 over 4 is 3 over 2 times root 5. So there we have the answer. The length of CD is 3 over 2 root 5. That's exactly what we had to show. And there we have the answer to part D. And now we're going to go to part E, which is, I think, the question that the student who asked me this question was really having problems with. This is a bit of a tough one, to be honest, but we have to just keep our head straight and, you know, answer the question. So now it says a point B lies on line L1 and the length of AB is root 80. The point E lies on L2 such that the length of the line CDE is 3 times the length of CD. Find the area of the quadrilateral ACBE. Okay, so to be honest, a question like this, if you don't make a sketch of the situation, it will be really difficult. So I would make a sketch. It doesn't have to be an accurate diagram, but it has to be kind of like, you know, realistic. Otherwise, you won't really see the shape properly. Okay, so I'm going to make a pair of axes. I'm going to draw the line 1 and 2. So for line 1, let's just think about where it passes the axes so we can make a little sketch of it. So we have 4x plus 3 equals 2x. Okay, so when y equals 0, x equals 3 over 2. So it's going to go through 1.5. And when x equals 0, y is going to be minus 3/4. So it's going to go through minus 0.75. So it's going to have a positive gradient. As we worked out, this gradient was, I think it was a half. Okay, that looks just about right. A half, that's the gradient of a half, that's correct. This has a positive gradient of a half. Okay, so it goes through those points. So something like that. It's just a sketch, it's not 100% accurate, of course. So that's the equation, that's line 1, okay, which is 4y plus 3 equals 2x. Then we have line 2, 2x plus y equals minus 8. 2x plus y equals negative 8. Now when x is 0, y is going to be negative 8. No, equals 8, sorry. 2y plus x equals 8. Let me write it the way I wrote it up there, sorry about that. So you have 2x plus, I thought there was something weird there. So 2x plus y minus 8 equals 0. Of course, when x is 0, y is 8. So it's going to be somewhere up here. And when y is 0, x is going to be 2x equals 8, x equals 4. So somewhere over here. I'm trying to make it a little bit realistic, but it doesn't have to be 100% accurate. So something like that. So you're going to have a negative gradient of negative 2, which looks correct. Okay, so there's line 2, which has equation 2x plus y minus 8 equals 0. Now they are perpendicular to each other, so I can't think I've drawn it just about right there. Perpendicular to each other. Let me make it a bit more realistic. They're perpendicular to each other. Okay, so there's a right angle there. We know that because they told us line 2 is perpendicular to line 1, and they both meet at the point C, which was, no, they both meet at the point 3.51. That was where they intersected, which we found. That's 3.5 and 1. And point C was a point on line 1, I think. Point C, line 2, sorry. Point C is a point on line 2, 2, 4. So 2, 4. Let's say this is the point 2, 4. Just say that's 4, and that's the point 2. That's the point C. So C is a point on line 2. Okay, 2, 4. That's the point 2, 4. Okay, so what else do we have here? The point B lies on line 1. Okay, so the point B lies somewhere in line 1. And AB, so what was A again? A was the point 9.54. That was a point that we had to find that, yes, that was 9.54. So point A is 9.54. So somewhere out here, I guess it's going to be over here. So I've made it the same level as that. So let's say that's 9.4. 9.5, sorry, 9.54. That's the point A. That's the point A. Okay, it lies on line L. 9.54. Okay, that's the point A, lies on line L1. Okay. Point B lies on line 1, and AB is equal to root 80. So from A to B is root 80. So B also lies on point line 1. Okay. Oops, what am I doing there? Let's work this out. So B also lies on line 1, and the length between A and B is root 80. Okay, and the point E lies on line 2, such that the line CDE is 3 times the length of CD. Okay, so if CDE is 3 times the length of CD, then E must be somewhere over here. Something to the pen is gone. Okay, so E must be, let's say E is over here, such that this length is twice that length. So we can say that DE is twice CD. Okay, so then that would mean, you see, the length of CDE is 3 times the length of CD. That's 1 part, and that's 3 parts, the whole thing, so that's going to be 2 parts. So this is twice that. Okay, and we also know that the point B lies on L1, so the point B is somewhere on this line. Okay, and the length of AB is the square root of 80. Okay, the length of AB is the square root of 80. So that means from A to B is root 80. So, for example, B could be somewhere along this line. It could either be on this side. So let's just say that's one possible place for B, or it could be on that side somewhere. Okay, somewhere over here, for example. That could also be a possible place for B. Okay, so let me just move some of these things along. just put these up here somewhere out of the way. Okay, so it's possible that B could be in either of these two places, and the distance between A and B is root 80. The length between A and B is root 80, so either that way or that way. So then it says find the length, or find the area of quadrilateral ACBE. So ACBE, so ACBE or ACBE. So it could either be this quadrilateral here, which I'll just draw. Let me choose a color to draw in. Okay, so we have, it could either be AC, B, oops, up in there, AC, B, E, could be that quadrilateral, or we could think of it as, I'll put this in like a dotted line, it could be A, C, and B, and E. Okay, it could be either this quadrilateral or that quadrilateral. Okay, both of them would have the same area, and that's what you have to find. So let's concentrate on this quadrilateral here. Okay, it kind of looks like a trapezium because of the way I've drawn it, but B, we don't know if it's at the same level as E, so you know, it's likely that it isn't a trapezium. So I'll just draw it a bit more like this, so that it doesn't look like a trapezium, because we don't know if it's a trapezium. So just in case that confuses some of you, let me just draw it like this. Okay, so let's say that's the point B. So we have this shape here, which is a quadrilateral. Now what we do know is this quadrilateral, these two lines go through the vertices of it. Okay, CE and BA, and those two lines are perpendicular to each other. So what we can do here is we can think of true triangles. We can split this up into two triangles, and because we know their vertical height. So for example, this triangle, let's call this triangle 1, the one I'm kind of putting in the yellow highlight. Make that a bit thicker so we can see it better. Okay, that's triangle 1. And then we have triangle 2, which is this triangle over here. Okay, so you have triangle 1 and triangle 2. So let's call this triangle 1 and triangle 2. This triangle has a base between A and B and a height between C and D. And this triangle has a base between A and B and a height between D and E. So we can find the area of each of these. We know the lengths of all of these lengths. So for example, for triangle 1, we have the area is a half times the base times the height, which is a half times the length of AB times the length of DC. Okay, so that's number 1. So that's a half times, now AB, we know the length AB, they told us the length AB is root 80. So it's a half times the square root of 80 times DC. DC, we know already from the earlier question, CD DC is 3 over root 2 root 5. So that's 3 over 2 times root 5. Okay, that's for triangle 1. Okay, and triangle 2, the area is going to be again half times its base times its height. So it's a half times, now the base again is still AB for this triangle here. The base we can consider AB. A half AB times, and this time is going to be DE. And we know about DE that it's twice CD. Okay, we just mentioned that DE. We know that DE is equal to 2 times CD. Okay, because they told us that CDE is 3 times CD. So CDE is 3 times CD. So that's one part, that's 2 parts. So that means DE is twice CD. And CD is, as we were told in the last part of the question, 3 times root 5. Okay, so DE is going to be 2 times 3 over 2 times root 5. So that's going to be 3 root 5. Okay, so that's the length of DE. We know that. So this is 3 over 2 root 5, 3 over 2 root 5, and that's 3 root 5. And we know that's root 80. So now we can find the area of this triangle as well. It's a half times root 80 times 3 times root 5. So if we simplify this, I'm not going to use a calculator as this was a non-calculator paper, just to keep that. So it's root 80, 16 times 5. I want to split it into 2 perfect squares. That's root 16 times root 5 times 3 over 2 root 5. So you're going to have 4, that's going to give you 4 divided by 4. So we'll have 3 times root 5 times root 5. That's 3 times 5. That's going to be 15. And here you have a half times, again, root 16 times root 5 times 3 root 5. So you're going to have, this is going to cancel with 4 to give you 2. So you have 6 times 5, because root 5 times root 5 is 5. That's 30. So we can say the total area, the area of the quadrilateral, which is ACBE, is going to be 15 plus 30, which is 45 square units. So that is the answer to part C. It's quite an involved part E, sorry. It's quite an involved question for 3 marks. I guess they only assigned it 3 marks so that they probably knew a lot of people wouldn't be able to do it, so they don't want to make too many people lose a lot of marks. So there's the answer. We could have got the same answer, by the way, if we took B as this point over here. I've made it a bit long compared to that. Let me make it a bit more realistic. So it's about, it should be the same length as that, roughly. Okay, so if we put B over there, it would have still been this triangle here and this triangle here. The area of this triangle is a half times the base, which would be the same height, times the vertical height, which is from the vertex to the base. So it would still be the same area, but here you can see it a bit more clearer. Okay, so there's the answer to that question. Other questions from this particular paper can be found in the playlist that will appear over here for this paper, if I get to answer any of them. Other questions from this topic or from this homework assignment that this is from will be found in this playlist over here. Other questions from the topic of straight line graphs from my Edexcel collection, you can find it over here. And I'll also put my Cambridge collection for straight line graphs in this playlist over here. Thank you for watching and see you soon.